Welcome back to part 2. So let's continue where we left off. So we had created our class, defined all the necessary things that we need. So let's add the libraries that we're gonna need. So I'm gonna need the IO stream, input output stream, and then I'm gonna need the C standard library for the cstd lib for the exit function, and then I'm gonna need the string stream for the toString function. So that's all I'm gonna need. So now I'm gonna copy all of this information and then add it to my implementation file. So I'm gonna create a matrix 2d.cpp and then add it to my project, then done. And then paste everything, and then let's set up the project, the implementation file. So I'm gonna fix this and remove that. And then I'm gonna do this. I'm not gonna declare, they already declared, I can do that. So I need to remove the constants. Then do this, and then do this, then do this. And do this, and do this, and do this, do this. I'll need this variables, and then do this. So with the destructor, what I'm going to do is I'm going to put it as the last thing at the end, because when you run your program, it loads the destructor automatically at the end once you're done using the object. When it's no longer in use, that's when the destructor comes to destroy the object. So I'm going to need to say hash include matrix.h so that it knows that what do I mean by matrix 2D. So this is a preprocessor directive. Remember, when I compile and execute the program, this file that I'm including is gonna include the information or the details about the things that I'm gonna use or the keywords that I'm gonna use inside of this file. For example, matrix 2D, it's defined inside matrix.h. There it is. So it will know once it's compiling. Oh, so when you say matrix 2D, you mean the class. Okay, then it won't shout at you. But then there's another thing that's missing. You need to specify, well, which class it's coming from. Remember that this is a constructor. It's not a class. I need to specify that this constructor is coming from which class. Basically, it's like sort of like implementing the standard namespace. So it's sort of like saying std and then string. It's sort of like doing this. I specify where the string is coming from. So it's the same concept that I need to do, that I need to apply here. I need to specify where are all these things coming from. So they need to be, I need to bind them with my class. I need to attach them with my class. The implementation needs to be attached to the class itself. And then pay attention to where I'm putting the code. I'm putting it next to the names of the functions because that's what I've defined. That's what's part of the class. If I put it in front of the integer, what I'm saying is that I've declared I'm the owner of this keyword, of which that's very false. It's not correct. Even putting it in front of const like this, that's very incorrect. You didn't create const. It came pre-installed with C++. How do I know? It's highlighted in blue. That it doesn't belong to me. What belongs to me or what I wrote from my own brain, it's this. That's the only thing I wrote. So you need to put it next to that to that name that you've created. And then set value, I also need to put it there. And then that's it. Now I need to say using standard namespace because I'm gonna be using tools that are inside of that toolbox a lot. Remember what a namespace is. A namespace is a toolbox. And then whatever tools we have, these are your C out, your C in, all of those tools, your string, all of those tools are defined inside the standard namespace. So I need to specify the toolbox so that when I use the tools, it knows what I'm talking about. So the default constructor, remember the default constructor or the builder that doesn't take in any information from the user, he's still going to build the same way or the same object, right? So he's still going to build, for example, in our example, we're building a matrix. But let's say, for example, you're building a house. Those builders, a house is a house. Let's say we have two different types of builders, right? The first builder gets information from the user and then they build based on the requirements of the user, which is this one. It takes in parameters. Those are the requirements from the user. Then the first builder or the second builder builds from what they're thinking, what they think is suitable or would be suitable for use. This is like an artist who just paints whatever they feel like painting. So that's the default. At the end of the day, you're painting or you're building the same thing, the same object. You're building a house or a matrix 2D. So I must use constructor chaining to chain and take that implementation and make it as my own. So remember that I'm gonna be coding here. So I'm gonna create variables here so that I can find a way to reference the parameters. So what's gonna happen here, I'm gonna pass in default values. So default rows, default columns, then default value. So what happens with constructor chaining is that it says takes the code that's inside of this constructor that I'm chaining to. How will it know which constructor I'm chaining to? Depending on the parameter list. How many parameters am I taking in? And what are the data types of those parameters that I'm taking in? Remember the default rows is integer, is of type int. Default calls is of type int. This is of type int. So it matches with this construct. So it takes in whatever code I write here, and then it pastes it here, but then it replaces the three values. Where it says rows or the first parameter, replace it with default rows. Where it says calls, replace it with default calls. Where it says value or the third parameter, it replaces it with default value. So just keep that in mind. That's what's happening behind the scenes. So now I need to implement the code. Before I implement, I need to enforce range. So I need to go in and enforce the range. So it needs to have a int lower. Okay, let me say int minimum. Int min, the minimum that's expected, and then int max. And then I'm gonna have int value. Right, I'm gonna have int value. For the enforce range, just it's a simple if statement. So I'm gonna say if int value, the value that I'm checking, if the value that I've checked happens to be less than my expected minimum, which is int min, output an error. I'm using this toolbox inside the standard tool. This tool, this tool inside the standard toolbox, which is CR. So I'm gonna say CR or output an error where you specify that the int value is less than the expected minimum of, and then I specify what minimum it is. The minimum is going to be int min and line like this. And then you're going to have exit, and then you're going to have error range. And then I'm going to do the same thing for my upper, for my maximum, I mean, not upper, what am I saying? Okay, int upper, whatever you want to call it, but max, for my maximum, I'm going to say, and then I change the wording. Instead of saying expected minimum, I say expected maximum. And then the maximum is stored inside int variable, int max variable. And then that's my code. That's everything I need there. And then now I'm going to enforce the range. So before I do anything, I must enforce the range of my rows. So what is the minimum? So it's min underscore value. And then the maximum is some max value that I've defined, max underscore value. And then rows. And then copy, paste. And then I'm going to have calls here. And then that's pretty much it. The value, I don't have to check it because they didn't specify that it can be positive or only negative. They didn't go into those details. I don't have to worry about the value. So it can be any value. So now I'm gonna store the value, that the inputs that I got from the user. So it's like, now it's like I'm at that point where I'm writing down the requirements of the user. Remember that these rows, columns, and value, these are the requirements of the user. So now it's like I'm taking down my pencil and paper and writing down so that I can store this information and use it to create the desired object. So underscore rows is equals to rows. Then underscore calls is equals to calls. And then for my array, I need to allocate memory for it. So new int, remember that is pointer point like this, and each pointer represents a dimension. Each pointer represents a dimension. So this out, I'm going to start with the outermost pointer. You always start with that one. That's the closest, right? I can't skip that one and start allocating. This one. We should start with the outermost, this one. So allocate this to underscore rows, right? And then once I'm done, for every single row, remember that's how a 2D is. A 2D is, what a 2D is basically this. It says 1, 2, 3, 4, like this, right? You create rows first, and then for every single row, you create the same number of columns. So for example, like this, row 1, I create this, row 2, I create this, row 3, I create this, row 4, I create this. There you go. There's your matrix. So I'm going to do that. So I need to go through every single row. So int r is equals to 0. R is less than underscore rows, and then r plus plus. And then I'm going to put curly braces. Yeah, I'm going to put curly braces. Wait. Is it necessary? Yeah, it's going to be necessary because I'm going to have more than one statement. And then I'm going to say it's less than underscore calls, and then C plus plus. And then here, I'm only going to have one statement, so I'm not going to put the curly braces. Okay, before we do that, I need to allocate I need to do the allocation now. I was still explaining it. Now I need to allocate. So if for every single row, that's what this means. So start at row 1, allocate this. At row 2, allocate this. At row 3, allocate this. And if you check, isn't this the same thing? It's exactly the same thing. So that's what it means. So say new int pointer. We've already allocated for that point. I don't need to write it again. So I just need to replace this pointer with square brackets and say underscore calls. So see this line of code, this is what it does. It does this. At every single row, allocate the same size at every single row. Depends on how many rows you have. But then it's going to allocate the very same thing. So that's what you're going to have at the end of the day. And then now what I'm going to do is at every single coordinate here, I go to this coordinate, I go to this XY coordinate, XY coordinate, XY coordinate, change this value to whatever value I want, which is the value that the user is going to give me. Wait, I skipped, which is this default value. So I'm going to say values at that specific RC coordinate. RC is the same thing as me saying XY coordinate. So that specific RC coordinate, set that to this one value. And then done. We're done with the allocation. That's all you have to do for allocating. Now I need to create a copy construct. The lazy builder, the one who copies out what other builders have built. It's like the people, those people who copy homework, whatever. Yeah, that's what this copy constructor does. It's similar to those people. It just copies what another person does. And then yeah, this builder takes credit for it. It's like, wow, you built this. Yeah. Where's the builder copied from another builder? So in order for me to build, I need to make sure that they are equal, the objects are equal. You can't try to, how do I put it? Yeah, you can try to print an A3 image on a or A3 text that is on an A3 image, and you try to make a copy using an A2. Yeah, it's not gonna work. It's not gonna fit. You see, it's gonna fail when it tries to copy. So you need to make sure that it's the same document. If the original is A4, then the copy must also be A4. Not that, for example, the original is A3 and then the copy is A4. They are not equal. They need to be equal in order for me to make an exact duplicate of that thing or a copy of that original. So I do constructed chaining and I say obj matrix dot underscore rows because these are the rows inside of my class. So obviously it's gonna match if I do this. I'm making sure that it matches. And then for the default value, for the value, I'm just gonna use default value because it doesn't really matter. Either way, it's gonna change. I'm gonna copy that. Either way, it's gonna change. And then now before we continue, let's asset. Let me use the C asset library. So C asset basically means make sure. So asset, when I say asset, what I'm saying is that make sure what you put in a condition. Make sure obj matrix rows is equal or has the same value as my current object. So something like that, like this. That's what I'm trying to do with asset. I'm just making sure that a condition is met. So for example, in order for you to get a contract, they make sure that you have a 3 months bank statement, you have a, a pay slip and things like that. Those are the conditions that need to be met in order for that for that transaction to be processed. It's the same thing here. The asset. Let's do that. How do we do the asset? You put in a condition, and the condition must return a boolean. That's it, true or false. Which is true because if you think about it, even when you getting a contract, if a cell phone contract or whatever, they make sure, is it true that you're a good paying client? How do they make sure? Or is it true that you are liable? You can fulfill your promises. They look at your track record and then they make sure that, oh, okay, then once they've made sure, that means it's true. It's either it's true or it's false. Then depending on the result, they either give you the contract or they don't. So it's the same thing here. I need to make sure my obj matrix rows dot underscore rows is equals to my current rows. They match. You don't have to do it because remember that I did constructor chaining and I made sure that they're equal before I copied. This object is equals to my current rows and columns. But it's just a great measure, just in case. And also I just wanted you guys to see it so that you can see how the asset works, how to use it, just in case in the future you want to use it. And then now I'm gonna do for int r is equals to 0, r is less than obj. Okay, you can use any rows because remember this statement, it means that they must be equal before we make the copy. Then r plus plus. Since I'm not gonna remember that the curly braces, you must put them when you have more than one line of code. What do I mean by line of code? You write something here and then you write something there. You see, this two is greater than one. So that's when I must introduce the curly braces. But for me here, I'm not gonna have more than one, so I won't introduce them because it's only gonna be one line, this for loop, the inner for loop. So I don't need to put the curly braces there. Underscore calls C++. Same thing here. I don't need to put curly braces for this for loop, for the inner for loop, because it's only going to have one line. What's the one line? So copy all the values of the object that I'm taking in obj matrix, this one, and put it as my values. That's basically how you copy. It's as simple as that. This is how you copy. Nothing fancy. As you can see, it didn't complain. But the moment you have more than one line of code, so for example, I type here, you see, now let me do this. If I type here, it's gonna complain because now I have more than one line. So now I need to introduce the curly braces. But in this scenario, I don't have more than one line. For the outer for loop, I have this one line, which represents an inner for loop. Within the inner for loop, I only have one line. So there's no need for me to make my code dirty and put curly braces. And then we are done making the copy. That lazy builder who just wants to copy other people's creation. I'm just gonna return underscore rows because that's what it's meant to do. It's meant to get the rows and it expects back an integer. So I use the keyword return to get back an integer. Which integer do I want? I want the rows. What's the variable that I declared inside of my class called for rows? What is it called? It's called underscore rows. So I return underscore rows. It's the same thing with my get calls function or accessor. I return the columns because it's meant to get back the columns. And then get value. It must take in a row and a column, X and Y basically. Remember it's a coordinate, XY coordinate. So return, what am I returning? Value. How do I find the value? It's inside the values array at specific row index, column index, X and Y. So this is my X and Y, row and column. And then that's it. We are done. Then I'm gonna have set value, right? It's gonna take in a row and a column and the value that I'm setting it to, that specific coordinate, XY coordinate. It's gonna take in an XY coordinate and then the value that I want to set for that specific XY coordinate. So underscore values, that specific X, Y coordinate, set it to value. So that's all I have to write there. And then before I forget, let's deallocate. So deallocation, I need to make sure what condition is met. Make sure that my underscore values array it has something for me to deallocate. Since there's no keyword called something, I'm gonna generate it. I'm gonna find a way to create it. There's no keyword called something. So how do I generate it? I say if I create a condition, if my values array is not nothing. Remember, null pointer means nothing. So if you negate nothing, what do you get? You get something. What is the opposite of nothing? It's something. So not nothing, it means something. In other terms, if let's imagine that let's say my Imagine that your calculator didn't have the plus sign. How would you find the plus sign if they gave you a task to find the plus sign without the plus sign on the calculator? Obviously, you'd say minus minus, right? Because minus times minus gives you positive, which is basically what I'm doing here. Not nothing, right? Which is basically, remember, not, you can translate that to a minus, and then nothing, we can translate that to also a minus. So now when I say not nothing, it means minus, and then brackets. Remember what brackets means. Multiply everything within the brackets by whatever's on the outside. This is just simple maths. So in essence, this is what I mean. Minus times minus. It gives you back a what? Positive. Whatever I'm looking for. I'm looking for something. So since there's no keyword called something, there's only a keyword for nothing, which is null point. That's the keyword for nothing. So I'm going to find a way to generate that something keyword by saying, make sure the values array is not nothing, or it's not equal to nothing. It's not nothing, basically, which means that it is something, or it has something for me to delete. I don't want to delete something that's already deleted. It's like, for example, there's this expression like killing a dead cow. You can't go and kill a cow that's already dead. I mean, it's already dead. There's nothing else to do. So something like that, you need to make sure that the thing is empty before you even try to do, even before you try to destroy it. It's already destroyed. There's nothing of it left. So remember that this is how it is, right? So it's like this. Remember how we're allocating. Let me show you a trick. This is how we're allocating, right? This is how we're allocating. We started by this, and then we did this, and then we do this, and then we did this. So now we want to undo those steps. How do we undo them? We start, if you check, let me undo. You see what's going on? It's deleting what? The columns first. So that's why we have to delete the columns first. And remember, I'm only gonna have one line of code. I'm not gonna put curly braces there. It's in the language itself. If you read the documentation of the language, even the author himself, Björn Strostrup, he has a thing about people not writing proper C++ code. So from now on, I'm just gonna try and follow that convention of his, like the reason why he created certain things. He says that if you have more than one line of code, you can put curly braces. That's why he created them. But if it's only one line, don't put them. So like this, it's only gonna have one line. So how do I delete? I use the keyword delete. And then what am I deleting? The columns dimension. Remember, it's RC, right? How do I specify that I'm deleting? I leave it empty like this to show that I'm emptying it out. And then there's a bit of a syntax thing here. There's something, you need to phrase it in a different way. The syntax is a bit different. So these brackets, you don't place them there. You place them immediately after the delete keyword, like this. But it still means the same thing. It's just that the syntax, the way you're gonna write it. Since I'm using namespace standard, I don't need to write this anymore. I'm just gonna delete that. And then I'm gonna create a string stream. Then I'm gonna return a string stream, but I call the string function to convert that stream to a string, because this function expects me to return a string. Then now let's output the two-dimensional matrix. How do we do it? We go through a Cartesian plane at every single coordinate. We start with X, then we go to Y, or we start with Y, whatever approach you want to choose. Yes, I started with X, with R, so I'm gonna do that. And then for int C, is equals to 0. C is less than underscore calls C plus plus. Remember, I'm not going to put curly braces because I only have one line. And then now I'm going to say, remember the string stream, it works the same way as a cout. Remember, it's a different type of a stream. That the O stream and I stream, the only difference, you see, I can also write this. You see, I stream. I is for input stream. This is a string stream. So it's still a stream. It works the exact same way as cout and cin. So I'm gonna use it here. I'm gonna use it as cin, as sort of like a no, as a cout is sort of like a cout string. So pay attention to the direction of these operators. They're going to that side, to SS, which means that I am inserting into the stream. This is, we're gonna get to operators, you're gonna understand it a bit further. But that's what it means. I'm inserting into the stream. I'm inserting this value followed by a space. And then once I'm done, I'm gonna put in, yeah, immediately after this, I'm gonna need to put in the curly braces because now I'm gonna introduce a second line. This is the second line. So put in end of line character. It should shout at me. There we go. Oh, okay. No, that's not the error that I'm looking for. Okay, it didn't shout, but it's supposed to shout because I have more than one line. Okay, it didn't complain, but it should complain. That means it is still bound to this for loop. It's still fine. Let's just test it out. Why am I saying more than one line? There's the first line. There's the second line. It's within the same for loop. So hypothetically should complain. But anyways, let's create a random function. So since I'm going to use the random function, I'm going to need the ctime library. And I'm only including it in my header file, in my main.cpp, because that's the only time that's where I'm using it. And those were not the requirements of the practical. They didn't tell you to put it inside the matrix 2D. So I'm going to put it inside here. It takes in a lower bound and an upper bound. Then I'm going to return the rand function, which generates a random value, modded by using the modulus operator by the upper bound minus modded by the range. Basically, how many values do I want it to generate? Lower plus 1 and then plus lower. What is this part? What does this part mean? The range. So the range is like this. For example, I want to find values between 1 and 4. How many values are those? Let's start counting. 1, 2, 3, 4. That's 4 integers. So let's calculate the range. So the range would be me starting at the upper bound, my stopping point, which is 4, minus my lower bound, my starting point, which is 1. 4 minus 1 gives me 3. But then wait, why does this seem a bit off? How many values do I actually need to generate? It's 4 values. So that's where the plus 1 comes in place. I need to add back a 1 so that I get back the accurate range. So now it's 4. That's the actual accurate range. You always need to add a 1. And then now we understand this range formula, how it works. Now let's see what this plus lower mean. Plus lower means that you are giving it a starting point. So remember that it's gonna start by 0. It starts at 0 by default. So since it starts at 0, I'm gonna add my lower, so it starts at that lower instead of 0. So let's say the lower that the user wanted, let's say it starts at 1 here, right? As you can see, you should start at 1. 0 plus 1 is 1. So it starts at 1 and the range is 4. So it generates 4 values. So start at 1. So 1, 2, 3, 4. It checks. Do I have 4 values? Yes, I have, which is exactly this. So it's just a way of us converting it into code. It's a bit of a tricky formula, but you'll get a hang of it if you practice more and understand the rand function and how it generates random values. Then I'm going to seed the random function to make sure that it generates unique values every time the program is run. So that's what I do here. Seed the random number generator so that it generates unique values every time, or else it's going to keep generating the same values. So I've called the function random, right? So now let me create random values. Remember that we have accessors and mutators. I have a mutator for my two-dimensional array. If you remember, mutators for changing the underlying values in the array. I have a mutator for it. And I have an accessor for my rows and columns. Before we do that, I need to create an instance of a matrix 2D, basically a matrix 2D variable. We usually call that an object. Because why are we calling it an object? Because when you create a class, it serves as like a blueprint, like a plan. And then when you create a variable like this, it means that the plan has been complete. You've made the object. You've built the house. You've applied the plan and then built the house. This house, by the way, it's using a default constructor. You see, I didn't pass in any inputs or any requirements. I didn't tell the user, I didn't tell the builders, okay, I want it to be this wide and this high, this big. I want it to be of this color. I didn't provide all those details. I just told them, build me a house. That's it. I don't care how you build it, what tools you use. I don't care. That's what's happening there. And then underscore rows. Okay, not underscore rows. Remember that we are outside the class now. I need to, as you can see, if I try and say underscore rows, you see, it's private. How do I know? It's the red. There's the color red there. It means I can't access it. How would I access it? Remember what the practical said. It said create accessors. So I'm gonna access it via this function called get rows. And then I'm gonna create another for loop, the inner for loop for my columns. C is less than obj matrix dot get calls, because now we need to use the what is this, the accessors that we were told to create. And then now I need to set the value by using a mutator called that we were told to create, to just set value. I need to set it for what row? That's R. What column? C. What's the value? I get the value by calling the random function. Generate a value between 1 and 9. Some might say, okay, why did you write it like this? Remember, the function returns a value. I don't have to do all those unnecessary things. For example, saying int value is equals to, and then I copy this, and then I paste it there. I return the value, right? And then I say the variable is equals to this. I say value. I do this. It's unnecessary. Just get straight to the point. Don't go vice versa. Don't go like, don't take the long route. Don't go, don't say you're gonna go there and then go there. Just go straight to the point. Don't take the long route. So I'm just gonna, at the end of the day, it's a value, right? Well, in essence, what you're doing, remember that this generates a value and then gives you back a value. What's the value? It's an integer. How do I know? The return keyword. So returns what? An integer. It's gonna return a value between 1 and 9 randomly. What's the value? Let's say it returned 3. And then here it's gonna put, and then I store it inside the variable value and then put 3 there. Instead of me just putting the 3 as it is there, I'm wasting time for it to go and do all those calculations. I could have just done this. Save time. And then once I'm done here, I need to output the string now, the matrix, through the string representation of it by calling the toString, and then inline character. And then now we compile. There we go. We have our matrix. I forgot to put in end of line character. Oh yeah, that's what I was saying. It's not gonna output it in correct way because now it's not bound to. That's why I wasn't complaining, because this was actually being edited at the end. So it was edited here. It was doing this. Yeah, that was wrong. So they just need to remember that. Should be fine now. There we go. There's our matrix. It has numbers, all of these numbers, random values. It's working perfectly fine. No issues, no problems. So now we're going to expand on this concept and add operator overloading. That's it for this session. See you in part 3.